So in this part, we'll talk about the gravitational potential energy. An object or a person stores the gravitational potential energy when it's at certain height with respect to a reference. This gravitational potential energy is due to the work of the weight. This means it exists when there's a height with respect to the reference, and each time the height is bigger with respect to the reference, then this means the object is storing more gravitational potential energy. So as formula, this energy is given by GPE equal mg multiplied by z, where z is m is the mass, g is the gravity, and z is the height, which can be written sometimes as h. Okay, and GPE is in joules. Now, this height, we have to pay attention that we must have a reference in order to find it, and that this height, this energy can be positive or negative. This is according to the Z. Why? Since if the object is above the reference, then in this case, we say that Z equal to positive the height. While if the object is on the reference, we will say that Z is equal to 0. And when the object is below the reference, we'll say that Z is equals to negative H, which means that the gravitational potential energy can have a negative value. Let's do a small application. A ball of mass 0.2 kilogram is dropped from a point A on an inclined plane at an angle of alpha equals 30 degrees with the horizontal. This ball reached the semicircular part of the path with radius r equals 0.2 meter, and it continues motion to reach the point D. We have AB equal 4 meter. So calculate the gravitational potential energy of the system ball Earth at the point A, B, C, and D. So let's start. GPE at the point A is equal to m times g multiplied by z. We notice here is the reference. The point A is above the reference, so this means the height is positive. But we look here, the height of A is not given. So first of all, we have to find it. We notice that HA is opposite to the angle alpha, which means that, so this is equal to plus HA, which is opposite to the angle alpha, which means we have to use the sine of the angle multiplied by the hypotenuse. So here the answer will become 0.2 multiplied by 2, and ZA, which is AB sine alpha, this means 4 sine 30. So as answer we'll get is 2 and divided by 2, so we'll get equals to, here it's 2, and we have 4 multiplied by half, so the answer will be 4 joules. Now, GPE at point B is equal to mgzb. We notice that B is on the reference, which means that the height is equals to 0. So this means here it's 0 joules. Now, GPE at the point C. Here we have to pay attention. So it's mgzc. C is below the reference. So this means that ZC is negative the height of the point C. Now, how can we find the height of the point C since it's not given? We notice here that this is here a semicircle. So this is here the radius, which means it's equal to negative 0.2 meter. And then we can find the value. So it's 0.2 multiplied by 10 multiplied by negative 0.2, which will give us negative 0.4 joules. We'll still have to find at the point D. So GPE at the point D equal mgzd, which is equal, here also D is on reference. So this means that Z of the point D is equal to 0. So GPE equal 0 joules. We'll do another application. So a ball of mass m slides from the point B into the point A of a height HA above the ground, taken as reference level. So give the expression of GPE of the ball Earth at the point B. So here, we just have to give the expression. So GPE at the point B equal mgzb. It's above the reference, so it's positive. So mg, height of the point B. Part 2. The expression now of GPE, but at the point A. So the same thing, we'll put the formula. So mg, also the point A is above the reference, so it will be also positive. So here the answer will become ZA, so mg height of A. Part 3, find the variation of GPE when the ball moves from B to A. So variation, when we say variation, this means delta. So which means final minus initial of which part of GPE. So delta GPE when it's moving from B to A is equal to GPE final. Now the final point is, so it's GPE final. The final point is A, so it's A minus GPE initial, which is B. So it's equal to mg height A minus mg height B, which will become mg height A if you have to take common factor minus height B. Part 4. Find the work of the weight when the ball falls from B to A in terms of mg height B height A. So we know that the work of the weight is given by mg initial height minus final height. So if we continue, the initial height is B, the final height is A. So this will be the expression of the work of the weight when it's moving from B to A. Now, last part, we have to determine a relation between delta GPE and the work of the weight. If we notice here, so here it's HA minus HB, here it's HB minus HA. So we can say that, if I want to write it in this way, so we can say that delta GPE is equal, we can take a common factor here, which is negative. So it's minus mg. It will become HB minus HA when we took the negative. So equal minus, now all this part is the work of the weight. So work of the weight. So we notice that the variation of the gravitational potential energy is equal to negative the work of the weight.